Hello my friends, and thanks and welcome back to the Galaxy YouTube channel. Today we are in Saratoga Springs, New York at the Advanced Semiconductor Manufacturing Conference. We've been doing a slew of interviews, and if you haven't seen any of those, you can click the little eye in the corner there, see the rest of the playlist, but today we have a special treat for you. We have Meixner here. She is an electrical engineer who spent many years with Intel, and now she's a technical consulting editor for Semi Engineering. Welcome to the show.
Happy to be here, Dan.
So tell us, I'm curious, how did you get into the semi industry?
You know, my first full-time job out of college was at IBM, just south of here in East Fishkill, New York. And there I got exposed to semiconductor manufacturing process, but in particular I became fascinated by defects because you need to prevent them, you need to detect them, but sometimes you just got to work with them. And I was just like, this is really interesting. I decided to then take a break from working and worked on a PhD at Carnegie Mellon, where I studied under Wojtek Mali, who was really big on understanding manufacturability and issues like that. And then I got a job at Intel, and unlike a lot of PhD students, I could apply exactly what I was doing, developing defect-based test methods at Intel.
Wow, that's rare, right? Because most people do their dissertations and they get a job maybe in a career, and then it's like, maybe you never use that, right? Maybe it's more like a plaque.
You kind of get tiered towards something else, but I lucked out in the sense that that perspective wasn't really at Intel as much at that time, and so that was, having that perspective, by taking that perspective, you can come up with different test methods. And I got to work with some smart people, and they're like, oh, why don't we do it this way? Like, that sounds like good, let's go make that happen.
Now, so throughout your career, did you stay in looking at defects, or did you branch off into other areas of semi?
Towards the end of my career, until I became interested in what a lot of people call data, how does analytics work into that? And Intel had decided, well, let's switch our design to system on a chip. All engineers they usually want more data.
Right.
What I ended up realizing was that to solve the engineering problem, it wasn't about a technology issue, it was having to solve the business problem.
You mentioned that engineers always want more data. That was their problem. What do you feel about the trends in the industry where now there's so much data, big data, that people are like, there's too much data, I don't know what to do with it. It's like the problem has changed.
You can make that argument. I think really what has to do with how do you take the data and do something with it, and do you need it now or need it later? And in looking at applications, whether it's from advanced process control, whether it's trying to deal something with the immediate future, I need to do something right now, or I need to be able to predict that something's happened, or I need to be able to, 2 years from now, connect the data that I have from the fab or the assembly and test site to something that happened in a field event.
Right, and speaking of that, I mean, when I was a project engineer, you'd do, like you said, a lot of the same things. You have a yield bust and you'd be going down, okay, well, which tester was it? Which load boards was it? Was there some type of commonality? And
right.
One of the things from the Orion aspect that we've been doing lately is a decision tree type agent-based algorithm where it's able to do the things that you would normally be doing anyway to help guide you and save you some time and be a little bit more efficient, so you can make the hard human judgment calls and let the computers do the things that you would do over and over and over again. It makes the engineer more efficient, and it gives them the more power to actually look at the harder things that a computer might not be able to see, because you still need judgment. Sometimes when you talk to engineers about, hey, we have this thing that can help you do things faster and that can find these defects, a lot of them go, wait a minute, I don't want you doing my job for me. We're like, no, we're just helping you. You're the one that has to make all the hard decisions from a human's perspective.
Yeah, there's a quote I like from Admiral Grace Murray Hopper, and she said, a computer's never going to ask a new question. You need trained people to do that.
Right. So, and you're a respected journalist with a strong following. So tell us, how did you make that transition, and why did you, from being an engineer to go into that side of it?
Well, arguably, I'm still an engineer. I do freelance work for Semiconductor, but I've been doing it for like 3.5 years. Being a pretty good networker brought that opportunity up. I wanted to tell my own engineer stories, but I wanted to capture other people's stories. And so I started off created a blog site, engineersdaughter.org, because I decided to call my LLC Engineers apostrophe Daughter in honor of my parents, who were both sort of technical in nature.
So clearly, and from those examples, you can tell that you're an engineer first, writer second. But speaking of engineering, how is being an engineer different from other jobs?
Because engineering is craftsmanship as much as anything else. So even if you're not solving a really hard problem, because engineers are the harder the problem, the more they want to solve it.
Right.
So they're very attractive. What is engineering as a profession? You can say professional problem solving, but it's also these tug of wars of what I like to say. It's no accident there are 3 E's in the word engineer, because if you look at a problem and sort of evaluate what the solution is, it's economy, efficacy, and efficiency. Right? Those are all things in there. And when I think about it from a test for defects point of view, I call it the yield, quality, cost triangle. Because you want to have high yield, but you don't want to have bad stuff go away. And you have to somehow do it in a cost-efficient manner. And a lot of times in a solution, you may have to come up, if there's a crisis going on, you're going to come up with a solution that is probably not the most economical, but right, you need to get the product out the door.
Right.
And you'll eventually work on the economy side of things. People often say, well, what you deliver as an engineer is improving humanity or making people's lives better. I would also say making a company's profits there. I've become a big fan, I haven't read all his book, of Henry Protowski, who's a structural engineering professor down at, I think, Duke, but got interested in history. And he counters the standard adage is necessity is the mother of invention, and he said no, failure is what informs invention and improvement. That if something fails, and it's commonly you learn more from failures than you necessarily do from successes.
Yeah, and failure just means you're one step closer to success. And what I like to say is failure isn't failure if you learn from it. Then it just becomes experience, right?
Yes, yes, I think that is.
So we just talked about experience. Clearly you have a lot of it.
Thank
what
you.
kind of, from your experience, what would you say to someone that's thinking about getting into engineering, younger kid, or even an older adult that's like going back to school, that's starting their journey in the engineering, and they're like, what would you tell them? What advice would you give them?
Your ability to work with others is vital in the engineering profession, because no engineer is an island. You're working with other people, you're depending on other people to get things to you. So the ability to relate to others and motivate or explain, this is what I need, can you help me? Being able to ask for help and not always thinking you have to do it. Just because you have to ask a question doesn't mean you're stupid.
Right.
It just means I'm not understanding this, or I think there's a gap of my knowledge. And that often sometimes when you're struggling with something, just getting up and going to talk to someone, you figure it out. Just go take a walk.
Yeah.
Or, come back tomorrow after a good night's sleep, staying up till midnight.
It's like the technical version of writer's block. I used to get that all the time too, and I would get my best ideas on my lunch breaks on my bike. And they said Albert Einstein, he said that he got his best ideas on his bicycle. So I see so many pictures of him on a bike. When I go for my lunchtime bike ride, like just what you're saying, it almost reboots your brain, and you look at things in a different way.
One of the things I offer in some of the training I've developed for engineering presentation is like, figure out who your audience is and make sure you know what's the purpose of this presentation.
What do you want to get out of it?
Often engineers totally miss that.
Yeah.
They're like, I will just send you some hours of work. It's like, well, why is this work important for them to do? What are you trying to convey? Why are you talking to them about it?
And this has been amazing. For those of you that don't know how to get in touch with you or how to read your writing, you just talked a lot about writing and how can they find your writings? How can they follow along with your work?
So I'm fairly active on LinkedIn, where I comment on other people's posts. I follow a number of other people who do engineer coaching that I like to, like I said, help other engineers grow. I post on there fairly regularly about, hey, here's this audience profile, exercise you can do to help prepare your presentation. So one way is to follow me on LinkedIn. For I write. I'm now writing 2, sometimes 3 articles a month for semiengineering.com, and I write for the Test Measurement Analytics, and I also write for, I'm starting to write for manufacturing materials and and packaging. And what's the publication is, post those on LinkedIn and puts my name on there, so I'm out there on that. But they also have newsletter that engineers in the semiconductor industry can sign up for. Oh, you want to know about low power stuff? Sign up for this thing. You want to know about that. So you get it delivered to your inbox, and then you can go figure out what you want to read.
Yeah, so if you're watching this, I'll put some links down below. You'll be able to click some different aspects of her work that she just placed there, and we'll link it to her LinkedIn profile. So Ann, thank you so much. This has been great.
You're welcome.